Good morning, I'm Al Koritz. I'm the Applications and Service Manager here at Electron Microscopy Sciences. Today I'd like to give you sort of an overview of the Q300TD system. It's a coating tool which will allow you to produce multi-layers without venting the chamber to change targets in between processes. Like its sisters, the Q150, the Q300, and the other Quorum instruments in the coating tool line, this one has the ability of doing multi-layers or dual process coatings. On the top plate, we have position A and position B, which allows you to install two different sputter targets. Many users we have use them for making contacts for MEMS devices, and put a chromium target in target A and a gold target in target B. And this system will allow you to coat with one and then coat with the other, or even if you want to make multi-layers, you can go back and forth between materials without venting the system. So what we are going to talk about is mostly the configuration of the substrate supports, the graphic user interface we will touch on briefly. However, it is virtually the same as the Q150 graphic user interface video I have already produced and is available on YouTube. It's just that this one will allow you to make multiple sputter processes under one recipe. So first, let's talk about the stage here. This chamber arrangement in stage is your typical arrangement out of the box, unless you've purchased some additional accessories, which I'll talk about a little further on in the overview. Here we have our dual film thickness monitors, which are also an accessory. I highly recommend that you add them. Right now I have the covers down to keep the crystals safe from contamination. When you're going to run process, you just lift the lid just like that and you're ready to go. System has a very unique stage arrangement. It has this gearbox which is connected to the central drive motor. You have the ability, depending on the size of the substrate and what sort of uniformity you're looking for, you can position the stage in its outermost position or its innermost position. The innermost position changes the center point under the actual target assembly on the sputter head, changing the uniformity of the thin film on your substrate. This happens to be a 100 millimeter or 4-inch substrate holder. I will demonstrate how we get from target A to target B. There's on the menu there's a recipe called Run Stage. So right now it's running at 70% speed. You can vary it from 0 to 100. And when it's rotating in a counterclockwise position, the stage will locate under target A. When the system calls for sputtering from target B after the process of sputtering from target A is finished, the stage will rotate in the opposite direction, and during this process it will shift so it is now under target B. So if you were doing chromium gold, chromium being an A, first you put down your 10 nanometers, let's say, of chromium. That sputtering process terminates at the right thickness because of the FTMs. The system will automatically stop the process, rotate the stage in the opposite direction, and this very cleverly designed gearbox will shift your substrate under target B so it can receive its gold coating. The Q300TD is also capable of coating larger substrates, typically up to 6 inch. And for that you need to purchase an accessory called a stop plate assembly. And this is the stop plate assembly. And what it does is it stops the back and forth movement at a position where your larger substrate doesn't hit the walls and allows you to coat those larger substrates. So right now I will demonstrate on how you would install the stop plate assembly if you purchase it. Place your hands at the center of the gearbox and just gently pull up. There's a shaft that inserts into the drive here in the stage. Once the gearbox is removed, you just set it aside for a moment. You unscrew this knurled nut. You drop those two holes over the back posts, which were the original stops for the stage, and allowing it to position correctly. You tighten down the retaining knurled screw there, and then you gently push the stage down till it bottoms out on the drive. And as you can see now, manually moving this, the stage does not go completely to this backstop, but stops at an intermediate position. That intermediate position, you would use the inner drive socket. You'd mount your 6-inch substrate holder, and we will run the stage. And once again, when it spins counterclockwise or anti-clockwise, the stage positions itself under target A. And when that process is finished, it will move and stop and spin clockwise under target B. Also, with this larger diameter substrate holder, you can't get away with having it on the outer socket, because then it impinges on the inside of the glass cylinder. So that's the stage mechanism in the 300TD system. By the way, 300 is the chamber size designation. T stands for turbo, and D stands for dual heads. We also have a 300TT, which is a turbo-pumped triple head sputter coater for some even larger substrates, up to 8 inches typically. And I'll demonstrate that one in another video. Q300TD target change. Take 1. 3, 2, 1. To change the targets in the Q300TD, the first step is to loosen the knurled knob on the target shutter, and that just gently is rocked until it comes off the pins and just set aside. Now it's really quite simple. There again are some knurled nuts here. Those nuts hold the dark space ring, which is at a different voltage potential compared to the target. This is the part that you need to periodically keep clean, because I don't know if you can see this real well, but there's little ripples along the edge. This is chromium that's not adhering to the aluminum of the dark space ring, and as you can see, I've pulled off sputtered material from the inside. You need to keep this clean, because if this material goes from the dark space ring at ground potential and touches your target, it will it'll short out your sputter head, and you'll not be able to run process until you clean it up. So that's just a little heads up there for when you purchase the system and you're ready to use it. So once the dark space ring is removed, the target retaining cap is simply unscrewed. And remember, magnetrons use some powerful magnets, so it takes a little effort to get it off, but it simply unscrews. This is the cover for the magnetron. It's just in there loosely, so there's really no need to take that out. Now, we used a 57mm target, and people might say, well, why don't you use a target that goes the complete inside diameter, which I think is about 63mm. Well, simply, we're trying to save you, the customer, some money, because everything that's under that lip ends up being waste metal once the target has gone past its useful lifetime. And you can, of course, send it to a metallurgy company and have it reclaimed, but why pay for an additional 5mm of metal that will just go essentially to the scrap heap? So we go with 57mm, which covers the inner diameter of the retaining ring. So once again, we just put the target retaining ring on the sputter head, screw down the ring until it catches the target, and then usually on these two holes I split the difference between the amount of material that can be seen of the edge of the target. And when I'm satisfied I'm centered, I just tighten the ring down so it's snug. There's no reason to use a lot of force. Once that's complete, the dark space shield can go back into place, and the two retaining screws or knurled nuts can be spun down to hold it tight. And then the shutter is put back into place, and its retaining nut screwed down so it fits snugly. Come on, there we go. So that's how you would change targets. Also, as an accessory that comes with the stop plate are two sputtering shields. These get screwed onto the front face of the dark space shield with the screws that come with it, and this causes some of the target material not to be sputtered onto your substrate, improving uniformity if uniformity is critical. I sometimes use these, but not always. It's a case-by-case basis. However, it comes with the stop plate assembly. Our standard thickness of our targets supplied are 0.1 millimeters thick. However, some laboratories might be interested in thicker targets, and you can consult our catalog or myself for the different thicknesses available. But they also come in 0.2 millimeters, 0.5, and we can make custom targets a bit thicker. But for all intents and purposes, half millimeter thick targets are generally what we recommend that you don't exceed. Now, if we add a thicker target, the target retaining ring moves forward, let's say a half millimeter, because you have a 0.5 millimeter target. So that closes the gap between the dark space ring and the target retaining ring. If you have a too thick of a target and you don't use a spacer, you'll short out the target retaining ring to the dark space ring, and the system will tell you that there's a short in the sputter head, and you'll be scratching your head why. So with thicker targets, we provide two for this particular system. These 1 millimeter spacers, which simply go over the two anchor screws for the dark space ring, and then the dark space ring just gets put on top of it and screwed down with the knurled nuts provided. And this increases the distance between the dark space ring and your target retaining ring, which is now extended a half millimeter or so closer. So this prevents shorting out. These are accessories that come with the system. You just have to remember to use them if you use a thicker target. After you have the system configured, the proper targets and spacers if necessary, and the sputter heads, your stage mounted, whether or not you ordered or require the stop plate assembly. You have your substrate holder in place. You would hopefully remember, even I sometimes forget, to lift the covers on the quartz crystal film thickness monitor. Of course, you make sure that the O-ring is free of the sealing surface on the base plate is free of dust, dirt, and debris. Little lint-free cloth with some IPA usually fixes that. You do the same on the top plate. As you can see, this is my laboratory demo system where I coat samples for customers and such, so they can be ensured that it will work for their particular application. So we fit the glass cylinder to the system. There is a liner plate that's available, so you don't sputter coat the glass like I've done here. And it has a slot in the front where you can put a glass slide in, and when the glass slide gets coated, you can just throw them out, and otherwise it keeps your glass cylinder clean. We use a large flat Viton gasket, not an O-ring. This gives the sealing surface a much greater area to adhere. We put a safety feature on the lid so the lid doesn't accidentally get bumped and come slamming down onto the glass cylinder. You have to physically release the latch to close the chamber. Now we're ready for coating our substrate. Okay, so let's talk briefly about the graphic user interface, or GUI as it's known. This is what happens or where you end up, the home screen when the system is powered up and booted. You have 5 basic areas to go. History will show you the event log, including various processes. It will give you, well, this happens to be venting, and that's not terribly interesting. So here's a silver process that I ran. So these can be outputted to a thumb drive. So this gives you a detailed view of the pump down cycle. Select target, system tells you what's going on. I use pump hold a lot. Bleeds the gas into the chamber, waiting for plasma, cleans the target, stabilizes, coats the target, and then terminates the process. That's the detailed view. You have process view, tells you exactly what parameters you're running with, and then message view, which is really not terribly exciting. For multi-user facilities, you have the ability to log in different users, which will limit the user's ability to change parameters and basically go to areas where they shouldn't go, where they can alter the system parameters, which might end up causing some issues. You get an administrator password, which allows you to manipulate certain parameters. If you're a basic user, basically you can just change the recipe to terminate at a specific thickness, and a few others. Right now I am in a high-level password, which allows me to change virtually all the system operational parameters. You won't have that that luxury. So the system comes with a complete materials library. So when you're making a coating recipe or profile, it asks you if you wish to use the default materials value, and almost always I reply yes on the screen to that. Then we have the system menu. Many of these at your level will be grayed out and you won't be able to make changes, but there's certain things that will be available where you can add and delete users, etc., etc. The menu that you'll be using most of the time is the process menu or recipe menu. Here you can see the run stage recipe, which I use to demonstrate the movements of the stage in this system. We have system vent. I have a stage test, which is sort of redundant from run stage. There's a couple of pump down menus depending on what parameters I set. There's a vacuum shutdown process, which will allow you to keep the chamber under high vacuum or a low order of vacuum when not in use. This will keep your targets cleaner, as well as the inside of the chamber, because it's not exposed to room air, allowing water vapor to adhere to things. If you're sputtering oxidizing metals like chromium, titanium, aluminum, you want to keep water vapor and oxygen out of there, because this causes oxides to form on the surface of the target, which are very difficult to sputter through initially, and will contaminate your sample to some degree. So we want to keep those out. So we have some single process where we're sputtering only one material. You can scroll left and right to see the various parameters that are set, or you can press one of those buttons and go direct to it. You can lock and unlock a process. You can edit a process. You can delete a process. You can duplicate a process. Over here we have just information about the system. This you can set the clock. You can add or remove users, and then again we have the home screen. So the unique thing about the dual head system is you can do multi-layers, as I said. So you can add a few different process functions. For instance, you can coat with chromium, and then in this case silver, and each process has a sub-menu that will tell you what all the parameters are. And these are all explained in the manual, or if you need to, you can always contact me for some guidance. So this is pretty much all of the graphic user interface information that is important. So there you have everything you need to know about the Q300TD that is not covered in the brochure. The brochure has quite a lot of information, options and accessories. However, this will give you an actual overview of how the system operates and how it might fit into your laboratory scheme. I even have some laboratories that are multi-users that will fit one material in target A and another in target B, and then the users can just initiate a single target sputtering. You can sputter independently from A or B or go back and forth several times. But if you have, let's say, chromium in A and iridium in B, and you're a multi-user facility, well, rather than have students changing targets back and forth and worrying about keeping track of targets, where they are, this laboratory installs a specific material in target A and target B, and then the students that come in can just select that particular sputter process from target A, target B. The system knows, because you input into the process what material is in target A and what material is in target B. So there you have it. So I'm going to end this particular demonstration by just doing a vacuum shutdown process. So I have the luxury of a chaseway here, so you couldn't hear the pump start, but now the chamber is sealed. The system will pump to 10 to the 0, and then it will terminate the pumping and roughing process and just go into standby mode until you wake it up to use it. I'll put my contact information on the end of the video, so you can contact me if you have specific questions. Thanks very much for your attention.